yesterday refreshed you on graphing points. We reminded you of labeling quadrants. Determining if a point is a solution, you just plug it in and check if it's a true statement. Looking at a quick way to graph lines using the intercepts, it only works if the constant is divisible by the coefficients. Then reminded you of the Algebra 1 way to graph, sharing my trademark slogan with you on graphing from slope-intercept form. We looked at graphing in the calculator, changing the window. We learned a shortcut for checking the standard viewing window, Zoom 6. We had an ugly quadratic. We graphed the critical values to get an idea of where it is. We went over the steps to do that in the calculator. We talked about the 4 words that all mean the same thing for x-intercepts. Then we hit the distance formula, which is from Algebra 1. We are going to level it up. We're not dealing with Algebra 1 stuff. This is college. But before we level it up, I needed to make sure you remember the distance formula. I showed you a shortcut to getting the distance. If you'll type the radicand in without the radical and then just write it underneath. If it will break down, you are expected to break it down. And here we are. Okay, so we're at example 7. So now we're looking at circles. Look at the directions. It says the point -2, 5 is on a circle that has 3, -1 as its center. Find the length of the radius of the circle. If you hear or read, find the length of a segment, then that's your indication that we're using the distance formula. In order to use the distance formula for the length of a segment, you need to know what the coordinates are of the endpoints of the segment. And in this picture, they give it to you. You have -2, 5, and you have 3, -1. So this is a straightforward problem. There's nothing tricky. It helps if you stack your points because then you can see your x coordinates and your y coordinates. So when you go to write the distance, which by the way, this is r. So when I write r equals, it's because I'm finding the length of the radius. Square root. Remember the formula is subtract the x's, square, add, subtract the y's, square. So I'm just going to write it. I'm not going to try to clean anything up. I'm going to, in my mind, read the formula and write the number every time I say x or y. So looking up here, parentheses, x minus x, parentheses squared plus y minus -1 squared. And then you can go to your calculator and you can type just the radicand in. Yeah, I think y'all are going to need, you are, because this is ugly. We're going to the next step on this. Bless you. Okay, go to your calculator, type everything except for the radical. notice that although I know that minus and negative translates to a positive, I don't write it when I type it in the calculator. I don't write it when I write it on the paper, because I don't want to mess up. I follow the formula. I just write the numbers as it is, and then I let the calculator evaluate it, because that's the simple math. I know that that's actually a plus there. I know this is -5, but if you'll just follow the procedure and then go to the calculator, you shouldn't run into as many mistakes. It does not matter, and the reason why is because once you subtract them, remember, order only matters if you're trying to have a positive or a negative. So you still have the same number, just a different sign, but then it gets squared. And so that always comes out positive. So you have 61. So this is the square root of 61. And if we look, I try to give y'all a heads up on what the computer's going to ask. So if the directions in the computer said round to the nearest hundredth, we would have to evaluate square root of 61, and it would be about 7.81. Now, in the My Math Lab homework, it does not give you a picture of the endpoints of the radius. It gives you the endpoints of the diameter, but then it says find the length of the radius. Divide by, yeah. So you would go through the same process to find the length of the diameter and then cut it in half, and that would be your answer. Does that make sense? I think that's question 10. Yeah, you want to do it at the very end. So you would go to your calculator and you would type the square root of 61. Be careful not to keep it under the radical. Go out and then hit divide by 2. And then it would be approximately 3.91.
If there's a perfect square in the radical that's asking as big as the radical, do you need to simplify it or like
Yes.
What would
Yeah.
click on the coordinate of that?
No, they would give, I'm just saying number 10 in the homework, they give you the endpoints of the diameter, but they ask for the length of the radius.
I mean, there's nine, that's the same thing, but it's asking for the coordinate of the radius.
On 9,
Yeah.
that I've got
Middle-
that
middle
coming up
circle.
on 11. Let me go through the next 2 examples because that's where we're practicing the coordinates. Okay, so look at this one. Y'all should remember the midpoint formula, because what does midpoint mean? Point in the middle, which means it's if you add the 2 up and divide by 2, if you add the numbers up, divide by 2, that's the middle, right? Here is the textbook definition of midpoint. This is the formula for midpoint. I wouldn't suggest memorizing it because it's as simple as, hey, I just add the x's, divide by 2, add the y's, divide by 2. Don't get caught up in the x of 1 plus x of 2, because then you might accidentally throw a plus sign in the distance formula. And honestly, I think I give you these formulas on a little formula card for the next exam. So you don't have to memorize them. You do have to know what D equals stands for. It stands for distance. You have to know that that is the midpoint. So look at this example. Find the midpoint. This is a straightforward problem. Whose endpoints. So they're telling you that you have this endpoint and this endpoint, and they want you to find the midpoint. So it's as simple as plug it in. Once again, I would suggest stack the points because your eyes, if they read horizontally, could easily mix a 5 with a -4, and that would give you the wrong answer. So if you stack them, then you can say, okay, here's my X's, here's my Y's, and then it's a lot easier. You minimize making a mistake. Can I write M equals here? No. So I put M equals, what letter did we address yesterday that is M from a line? Slope. So there's no symbol for midpoints. The way that I write it is I just do MDPT. So because there's no symbol, there's no notation for it. All right, so it is going to be a point, which is why it's in parentheses. So you've got to add the X's, divide by 2, add the Y's, divide by 2, and anything that will not divide by 2, leave it as a fraction if it's ugly, or if it's a pretty decimal, you can write it as a decimal. I left both of mine as, I put mine as decimals. In my math lab, the one that I had was both of them were fractions. So this is -2 over 2, right? And this is 3 over 2, which is so that is the midpoint right here.
So you just find the difference. You just fractions of each other, find the difference between two numbers, divide that by 2. Add that to your numbers. You make the little that makes sense.
No, don't. Yeah, different. There's no difference here.
No.
You're finding the average. Midpoint is average. So the average of the X's and the average of the Y's.
No, I mean, like, well, I did, as time we call each other, it was negative 4, 2, and so it was 6. And I got 10 by the 2 is 3. And if I add 3 to the negative 4, then I get 1. Yes, the next one. So basically, 5 and negative 2, so it was 3.5. Right? 3.5. 2. 1.5. Or you can.
If you do this, you'll be done. One step.
That was weird. See, I felt
If
like
you're-
talking, but it wasn't otherwise.
Okay. I'm not really sure what you did. So I don't know if it was coincidence or if you just see a visual way to do it that works. If you want an algebraic way, you can use this. Okay, let's level it up though, because this is algebra 1 level. All right, here we go. The diameter of a circle connects the points on the circle. Find the coordinates of the center of the circle. When you first read it, you might think this is like some really difficult type of question. First of all, visualize it. You have a circle, you have a diameter, you know what that looks like. They gave you the endpoints of the diameter, and then they ask you to find the coordinate point of the center, which is, they don't want the length of it, they want the location, which is the midpoint. This is a basic midpoint question, but it has been disguised under a circle. I don't really know how that happened. This is a basic basic midpoint question. It's just been disguised using circle properties. You do have to make sure that what you're trying to find is the middle point, and you have to make sure that what you have are the two endpoints, because you are going to get examples where they give you one endpoint, one midpoint, and you have to find the other endpoint. So you do have to make sure what they give you that you put it in the correct location. So the midpoint or the center, right, of the circle is going to come from averaging the x's, which you could do in your head, but I'm going to write it out so you know where it came from. And then averaging the y's. Now, why am I writing 4 minus 3 here? Because this is going to be 4 plus negative 3, and I'm just going to go ahead and write, so that's 4 minus 3. So you get 4 comma 1/2 or 4 comma 0.5, right? Depending on how my math lab asks you to answer it. So this is the center. That's the center point. We have 4. Let's see. Let me double check. All right. Determine the center. I don't have it in my math lab. So last year when we went through this, I did every homework assignment through here and pre-calc in here so that I would know what to tell y'all. Hey, heads up on this question. I don't see it in here, but I've seen it before somewhere and I can't remember where, so I'm going to show it to you. What if, and this is an incomplete sentence, and I don't even know if it's pretty, so I'm not going to work the whole thing out. What if I gave you an endpoint of 2, 5 and center negative 1, 4, and I asked for the other endpoint? The first thing I would suggest is sketch a little picture. Doesn't have to be on a coordinate plane, doesn't have to be accurate. Just sketch a picture to get an idea of what I've just given you. So I gave you one endpoint and the center, and I'm asking you to find the other endpoint. So in this case, you cannot just shove these in the midpoint formula, average them and divide. You can't do that because that's assuming that these two are the endpoints and they're not. So if you get one of these, you still set up your midpoint formula, but you're going to have an x and a y in here, like an x and a y that you don't know and you have to solve. Okay? So looking at the x coordinates, you have to think to yourself, this was the center, right? So the center x coordinate's negative 1. You have to think, what could that come from? It came from 2 plus some type of x divided by 2. Does that make sense? I didn't write it as a coordinate point because I didn't want to have too much going on. I'm doing just the x. So the x value of the midpoint came from adding this x value to some other x value and cutting it in half, right? The average. And then the y coordinate would be 4 came from 5 added to some number that we don't know, cut in half. Okay? And you would solve that. You'd multiply both sides by 2, then you'd subtract the 2 and the 5's over, and then you would have the other endpoint. And you could check it by taking the other endpoint and the given one and just finding the midpoint, and it would be that one right there. Okay? I don't know if that's going to come up. I've seen it somewhere. I don't remember where I saw it, so I'm showing it to you just in case. It is not in my math lab homework from last year, but in case it comes up, now you see it. These were the y coordinates, these were the x coordinates, and you would just solve that, multiply by 2, then subtract. Alright, now let's go to the actual definition of a circle. The definition of a circle comes from, or the formula for a circle comes from the distance formula. So let's look at this. This may ring a bell. The center of a circle, the center point of a circle are the numbers in the positions of h and k in the equation for a circle. You will notice that right here there is a negative. You see this and this? Anytime there's a negative in a formula, it means there's a sign change going on. It doesn't mean it made it negative. It means it negated it, which means if it was negative, it became positive. If it was positive, it becomes negative. Negate means it's a verb. It's changing its sign. Does this look familiar? This is the length of the radius. We just did it 2 problems ago. We found the length of the radius from an xy coordinate and the center we're going to call hk, and we plugged it into the distance formula, and that gave us the length of the radius. Y'all see that? That is the equation for circles. We're going to tweak it a little bit because this is really ugly. Nobody wants this giant radical. What is the opposite of square rooting? Squaring. The opposite of square rooting is squaring, right? Okay. I stalled a little bit. Really messed up in 3 slides. But you missed a whole conversation about me, and I'll just have to catch you up. I'm just kidding. So come right here. I'm gonna copy that over here, and we're gonna play around with it. So we've got r equals the square root of this mess, right? So I said, what's the opposite of square rooting? Squaring. I'm gonna change colors so you can see what I'm doing. I don't like this. I'm going to manipulate it so it's cleaner, and I can do this because this is a giant square root over that entire mess. I'm going to square the whole thing. I'm squaring the left, I'm squaring the right. So what's r squared? R squared, right? And then what happens right here? That cancels. All that mess goes away, leaving me with the radicand. Now that looks a lot cleaner. I'm going to reverse it. I'm going to mirror image it because the normal way to see the equation of a circle is this mess is first and r squared is second. So I'm going to write or, and I'm just mirror imaging it. Now, this is the one I want you to box in. I feel like I'm in a fighter jet when I say that. Box 1. I probably will be one day. Simulator. What's these? Box it in. And I want you to write, this is the equation of a circle. I did date a fighter pilot one time. Just gonna say he was a F-18 fighter in the Navy. Like, how'd that look? He flies for UPS now, then for FedEx. Because he retired. I don't know. I'm No, he flies those big, giant, like 747 planes. I'm over here just teaching math. Yeah. And my husband connects wires for cable TV. And it's okay. It was meant to be. All right. What is the center? It is HK. I put an asterisk. I put an asterisk for a reason. I want you to put an asterisk here, and I want you to write, this means Miss Holcomb's way of saying there is a sign change. Do what? You got it, Jason. I believe in you. I believe. I believe that you. I believe that you will write. Let's label one more thing. If I tell you that here's a point on the circle, this is what you're going to see. You're going to see the phrase, given the point on the circle, and then that means it's X and Y. That means it's X and Y. And then if I tell you the center, that means it's H and K. So there's a difference between the two, okay? If it's a point on the circle, it would get plugged in position of X and Y. If it's the center, it's going to get plugged in the position of H and K. And that matters. Because look at what the order is. Okay, so now let's practice it so you can see when is this going to happen. Is everybody good here? Okay. I copied the equation over so that you didn't have to flip back. Let's read the directions. Find an equation of the circle with a radius of 5 and a center of 3, -7. First of all, box in this so it'll draw your attention to it. And I do give you this formula on the test. You don't have to memorize it. Remember, there is a sign change on H and a sign change on K, and it's the center, right? Now, the picture that's drawn here is irrelevant. This picture is really not even reading. I probably could delete it. Find an equation of the circle. So, biggest complaint about math is people say, I didn't know what it was asking. Read the question, underline it to help you stay focused on what it's asking. It wants the equation of the circle, which means your answer should mimic the formula for the equation of a circle. Now you look at what they give you and label it. They give me that R is 5, and then they give me the center, which are what letters? They give me H and K. When I go to plug them in, there will be a sign change on both of them. So we're going to plug it in. Here we go. Parentheses, X. I don't have an X, right? So you're going to write the letter because you're writing the equation. H. H is +3. So I'm going to write -3. Remember the sign change. Plus Y. K is -7. So I'm going to write +7. Parentheses equals. Be careful here. It's R squared. Which you could rewrite the whole thing, or you could say, oh, R5 squared is what, y'all? 25. Now I am going to come right here and I'm going to show you that came from R squared, which was 5 squared, and that's why it's 25. So when you're looking back, if you're like, where'd she get the 25 from? Because you have to square R. That's it. That's the equation. of this circle. We're not solving anything. Read the directions. Find the equation. That's it. Don't make up new math. You can't solve this because you have an x and a y. And we don't solve circles. Right? You think about it. We either graph them or we find the equations for them. Yeah. All right, 2 slides left. We're going to practice with circles. Graph the circle. Now, when you go to My Math Lab to graph, I think you plot the center first with your mouse. You put the mouse where the center is, and then you second click, like count out with the radius. The way that I'm fixing to do it on here is the way that I think you have to do it with the mouse, so I'll show you. In order to graph the circle, we need to know, this is the way that I arrange it in my mind. You need 2 things to graph it. You need to know the center and the radius length. Once you know those 2 things, then you can graph it. The center is going to come from the numbers in the positions of H and K. Don't forget there is a sign change on both of them. Whatever you see in the equation, when you go to write it, you're going to have a sign change. I see 5, -2. So my center is actually -5, +2. And remember, this is r squared. This is where a lot of people mess up, is with the r on the end. They think the number on the end is r, and it's not. It's r squared. So r squared is 16, which means we have to do what to it? We have to square root it. So r is 4. Now here's how you graph it on paper, and then I think, if I remember correctly, this is how the widget in My Math Lab wants you to graph it. You're going to put a mouse. First of all, you click the button that has a picture of a circle. Just say, hey, I'm graphing a circle. Then you put the mouse where the center is. So 1, 2, 3, 4, 5. Put the mouse where the center is. And then I think the mouse is now basically going to draw the radius. So you just count out what? 4. Now you have free choice of what direction you're going to count. I would not count this way, or this way, or this way, or that way, because you can't see 4 diagonally, right? I would count in what I call the cardinal directions, either 4 this way, 4 this way, 4 this way, or 4 that way, and then you'll click, and it'll place a point on the circle, and it'll pop open the circle, like it'll draw it. Okay, I'll pull one up. It's pretty bad, but I'll pull one up, and when we finish. I do want to give you a what if question, because if does it happen? Yeah, it does happen. I want to give you a what if. What if at the end of the equation r squared was 2? We were going through this whole thing, and you had to find the length of r. Well, if r squared is 2, you still have to take the square root, right? Okay, and because 2 is not perfect, it would be left at the square root of 2. I don't think they have you graph any circles where the radius cannot be counted out. If it does have you graph a circle where the radius cannot actually be counted out, it will have a widget where you can type. It'll say R equals a box, and you just type square root 2, and it will project the circle with that length. Okay. You do get a square root, or like a radical on one example. When you find the length of the radius, it ends up being the square root of 2. The length of the radius is. Alright, last example. Graph this circle. Honestly, you could throw this example out. It's the same. That's the name you need to practice. While you're doing that, I'm going to pull up number 15 because it's one that I feel like some people are going to have questions on.
So the media things.
You have to click them.
Yeah, like you want us to read them really like.
No, you have to click the link for it to give you the credit, but you don't have to watch it. It's there if you need a refresher. It's probably not going to let me go to it. No, let me go here. Book tools. Why is it doing it? Yep, okay, 15. We'll do that one next. Let's answer this one. So, did you get a center of 2, -1? And r squared is 16, so r is 4. So 2, -1. Okay. You might want to add this to your notes. Question 15 from my math lab. And I don't think I can't zoom in on it. So let's see, I can do this. Wait a minute. I'm gonna delete this. I don't like it. Insert page after paste. I thought I could make that bigger. Anyways, okay, let's look at this one. This is question 15 on the homework. Find an equation for a circle. Okay, so you know your final answer should be of that, x minus h squared plus y minus k squared equals r squared. They give me the center is -6,5. Then it says, instead of telling me like there's a point on the circle or the radius is whatever, now it says tangent, and it reminds you what tangent means in math. It means touching at one point. In geometry, y'all learned about tangent lines. It's when a line is approaching a figure and has only one point in common. If you zoomed in really close, they would only have one point in common. That's on both the line and the circle. So they're saying there's a tangent to the y-axis. I think the circle's on the other side. So that picture, and I'll blow it up. This picture, no, I can't. I forgot a carbon. There we go. I can do it. Hold on. Which one? Will it? Does it have a pop-up? I just messed it up. Not that much better, is it? Come over here. Let me paste. There we go. Put it over that. Okay, it's slightly better. Not great. All right. So looking at the picture, the center is -6, 5. And then they're saying that it's tangent to the y-axis. That is a very sneaky way of saying trace the edge of the circle, and once you hit the y-axis, the point that you land on is a pretty point. So if I'm tracing this circle and I hit the y-axis right where it looks like it's touching, like not that one, it looks like it's touching in 3 spots. So it would be the middle one, because the tangent only touches in one spot. So it's going to be right here, which makes sense because it should be right across from it, right? If you think about it. So now you have 2 ways to finish this. Now you know a point on the circle. It's going to be 0, 5. But you also could just count the radius from the center to that point, which is your x-axis. This is -5 to 0, so the radius is 5. No, it's -6, isn't it? It's -6 to 0. Did I put it in the wrong spot? No, 4, 5, 6. Yeah, I'm at -6, 5, and this is 0, 5. So the radius is from here to here is the length of 6. So 2 ways to finish it. You could just run with the center radius. If you didn't know the radius, let's say for some reason you didn't think to count it, then this is your H and your K. Don't forget to sign change them. And this is your X and your Y. And you would plug those in equal to R squared, and it would give you R. Okay? Take the square. It's going to give you 36. Take the square root of it, you're going to get 6. So let me show you what I mean. X minus, so sign change, squared plus Y, sign change, squared equals R squared. That should be 36. And it is, because look, this is 36, and that's 0. So if you forgot to count the radius out, you could plug in that point as the X and the Y and just find the R squared. That's going to happen on question 15. All of the other questions I'm looking at look fine. You do get number 12. It says the endpoints of the diameter are radicals. Let me show you. Number 12. It says these are the, now these are my numbers, yours will be different. It says these are the endpoints, and it asks you to find the midpoint. They want you to type it in exactly how you see it, which would be a giant fraction, square root 7 plus square root 3, and in the bottom of the fraction would be a 2. It's the midpoint formula, you just can't clean it up. The equation of the circle would be parentheses x plus 6 parentheses squared plus parentheses y minus 5 parentheses squared equals 36.
Wait, you did do square root of 5 on that one, on the result. You do a square root of 5.
No, I was saying that when you write the midpoint of this, like the x coordinate is going to be ugly, and they want you to leave it as is. This would be -2 over 2 to -1. They just want you to leave the formatting like that. You can't add those.
The answer is R equals 6.
No, that's not the answer. I was saying that's how you should find R.
Oh,
No, the answer to 15. That would be the answer to 15. Yep, I'm sorry.